the reference material that you need to learn this course. Again, the prerequisite, let me just mention the prerequisite of this module. The prerequisite of this module is we have to remember that the statistics means that the O-level statistics, the O-level and the, let's say, A-level or diploma or ordinary diploma statistics and the probability. So those are the prerequisites of this module of course. And then the post-requisite, the good news again, in engineering, in most of the engineering post-requisite, most of engineering programs and scientific programs, we used to have to learn some modules known as research. So many of the concepts you may cover them in research. So you say that the prerequisite, the post-requisite, we need this knowledge in our postgraduate, or you need this knowledge of this module in postgraduate studies, and this will be based on the research, right? On the research. So this for the masters, and maybe you are doing master research or research in master degree or in PhD or doctorate studies. But also another prerequisite or area of applications of this module or this course is real life. Means that solving, or we need this course on solving real life problem. Solving a real life problem. From the paper, maybe we design a system, particular systems, real life 40 problems. So you may use this concept to solve real life problems. So those are all about the prerequisite, post-requisite, the reference books for this module, where is this course is being taught, how do you learn it, what are the requirements. So now I would like to take you into another fantastic part, where I'll be giving you the contents and begin to cover the first contents or the subtopics, call them the subtopics of these modules, subtopics and contents of this course. I use the word course and contents interchangeably. Don't get confused on that. So now let us go to subtopics or contents. Go to subtopics and contents. Contents of what? Of this particular chapter, which is the recommended reference book is Statistics for Non-Majors by Mohammed or by Dr. Mohammed. Subtopics and contents of 40 of estimation of this topic of estimation. Okay, of estimation. What are we going to cover in this topic? Well, that's a good question. So because this chapter 6, I can use 6.1. I will make introduction, or have been making introduction. So introductions of 40, introductions of estimation. So today I will cover this concept or this subtopic, introduction of estimation. And then the second subtopic, I will teach you about point estimation. I'll do some examples. Point estimation. And also I will teach you about the interval. However, that I won't go into too much details. Interval estimation. But another concept, interval estimation. Then I'll teach you 6.4, where I'll be teaching about confidence interval estimation for a population mean. I'll teach about confidence interval, very interesting part. We'll be enjoying because we have interval estimations and we deal with continuous random variables. Confidence interval estimate for a population mean. for a population mean. For population mean, when variance is known. When variance is known. When variance is known. So 6.5. Next is some topic equality estimation of difference. I will teach about confidence interval. Say confidence interval. These are the new terms for you, or maybe you are familiar with confidence interval estimate. For a population mean when the variances are known. For population mean as a statistical variable, I still didn't use this mean. Population mean when what? When variance is unknown. When variance is unknown. Okay? That's the fifth subtopic. And then, after we cover that sixth subtopic, or 6 contents, I will teach about estimations of difference between means when population variance are known. And there will be solving problems, don't worry about that. Okay, I'll teach you the concept, giving you the formula, and then solving the problems. And then so you'll be thinking, how can I use this knowledge to solve my own problems? Estimation of difference. It's estimations of difference between means. Between means. Okay? Between means. When population variances are known. Population variances are known. When population variances are known. Then we go for 6.7. Estimations of the difference between means when population variances are unknown. So similar. So you say estimation. I'll be teaching how to estimate estimation of 40 of the difference between means of difference between means when population when variance, not population, excuse me, when variance is unknown or unknown, when variances are unknown, when variances are unknown. So the last subtopic is for problem solving. The last subtopics of the last contents of this module is problem solving. Right? So 6.8, we'll be solving problems now. Problem solving by using all the reference or some of the references that I've mentioned, okay, from textbooks, problem solving from textbooks, from question and answers books, okay, from UE, university exam, from tests, etc. So that there is subtopic of 40 in these concepts of 40 of estimation that I'll be teaching you in this exclusive and fantastic lecture or programs of 40 of estimation. So at the end of this topic, you will know how to do estimation statistically, or how to do estimation. You know that the issue of estimation is very important. We used to estimate the budgets at the beginnings of the months, or we used to estimate maybe studying budget, tuition fee budget is going. For example, the national estimations for the undergraduate students, they used to have a loans of 8,500 per day. So that's the estimation. So I mean the government has done the estimations on the requirements and basic requirements of undergraduate students. So the concept of estimations is very important. But now, how you can do estimation mathematically? So this is dealing about the groups and number of objects. You can have maybe a compound which is having a large number of people, so you have to enroll them. So as I say that, the subject of estimations is very important in the human life. We're estimating the large objects or large things and even the small things. So today, in the progressions of this lecture 1, so session 1, let me teach you the introductions of estimation. So that's the subtopic that we have to cover, and then we end this lecture and we meet in the second lecture. So introduction of estimation. So I won't go into too much details. If you want the concrete concepts of introductions of estimation, watch the videos in the playlist known as Probability and Statistics for Institutions. When I told the third chapter there is called estimation, statistical estimation. So introductions of 40 of estimation. So first of that we use the statisticians used to tell that, and it is true, that 60% of Tanzanians are youth, are teenagers. So if you 60% figure, then suppose that maybe Tanzanians are 50 million. So 60% of 50 millions, you know, it's almost 30 millions, right? 30 or 30 something millions, you see. So if you 30 millions, can you imagine now if you want to do a research and then you want to research that the problems existing between or among what problems existing for existing to 30 million people. First of all, you'll face many challenges, but two main challenges you'll face. Number one, the sample. It means that the populations, the size of the populations is very large. You cannot do maybe the interview for all the 30 millions youths or teenagers. It's difficult. Again, you'll spend much time on your research. Yes, you can say that, okay, I'll employ a number of people and whatever and so forth. So you find that, number one, first of all, the size of the sample is large. You cannot reach all the teenagers. Number two, it's very expensive. Number three, again, it's time consumptions. So because of those three problems, what statisticians told us now, how we can fix the problems that we have, because we still need the mean, the variance, the standard deviations of the particular physical quantity. So then they told us we can do estimation. How do we do estimation? It means that for the whole large sample of the teenagers in the United Republic of Tanzania, we just take a sample of, let's say, 1 million youths or teenagers, and then we compute all our statistical parameters that we want, maybe mean, variance, and the standard deviations. Then we estimate for the entire populations of 30 millions of the teenagers in the United Republic of Tanzania. So that's how the study of estimations is coming. Drawing a sample from the finite or infinite population, do the statistical computations and estimations of the particular parameters, and following the procedures and steps of selecting the right sample or the accurate sample, so these estimations will be correctly to the real or the entirety population. So that's the problems. So in practice, it's not always possible to work with the world population and determine the desirable statistical measure. That's the problems. Okay. So in practice, practically, okay, in practice, it is not always, it's not always possible to work with the world population, work with the world population and determine the desirable statistical measure. Determine the desirable statistical measure. Okay? Or measures. Example, like what it means, like what statistical measure, like mean, and what mean variance, and what is standard deviation. Standard deviation. So it's not possible. So what we do? Okay, this because the populations might be infinite or very expensive to work. Why? So the question is why? Because it might be number one, time consumption, number two, it may be expensive, and number three, you might be doing the research on the infinite population, large size of 40 of population. And you won't get even sometimes, it's difficult for you to estimate from the collections that you've made, because some of them will confuse you. Then the large size of 40, large size of population. So these are the three challenges you'll encounter if you want to do it in practice. So how do we do, or how do we solve problems? So solutions of the problem. Okay, we'll go to the mathematical point, but just you want to do the solid introductions for you to understand. So you see the solution now, we say that we have to, so you say that to solve the problems, we have to draw a sample, right? By using sample techniques, because there are sampling techniques, by using the sampling techniques, because it is a trick. You have to learn how you can choose that sample, because if you don't follow these sampling techniques, you won't get also the estimation. So you have to draw a sample by using sampling techniques from either finite or infinite population. Do you like engineering mathematics? Do you like scientific mathematics? Tell me in the comment sections. For me, I do like and I do love engineering mathematics, especially for the statistic. Yes, this is one thing that I used to hear. When I was in O-level, we had a topic called the statistic separate with probability. And you know, our elder or other students who were in the next classes who did the programs or learned the probability for the Form 4 and statistics for the Form 3 used to just like used to tell us those topics are very difficult. But believe me that they are not difficult. When you go for ordinary level and even go for advanced level, there is a belief which induced or transmitted from one generation to another generation that probability and statistics are difficult topics. And even when you came for undergraduate studies or bachelor degree studies, you hear the same slogans. Please, I would like to say that cancel that idea. These are not difficult topics, but they are very challenging. Yes, they are complex. They are a little bit, they are too much complicated and too much actually difficult. But we know we can spend much time, and I'll be teaching you and making it simple in such a way that you will never afraid, even at any times that you can attend the interview or maybe the exams that you're asking about this one. From either finite or infinite population, okay, and then after doing that, and then you estimate. So you see now the concept of estimation. Estimate what the statistical parameters. Estimate the statistical parameters. So what are the statistical parameters? Mean, variance, and what? Standard deviation. So we say that estimations are the formulas used to estimate the population parameter. So then now we can the point. Okay, so at the point we need estimation. Good. So what is estimation now? So let me give you one of the definition. So we say that estimation. So the question now, what is estimation? Okay, what is estimation? So you say that estimation are the formulas. So these are the collections of the formula. As the formulas used it to estimate. So these are the formulas used to estimate what? Used to estimate the population parameter. Used to estimate what? Population parameter. Populations what? Parameters. So we use these estimations are the formulas. These are the formulas we use to estimate population parameters. Example of these population parameters, when we mention population parameters, we mean mean, we have a means that mean, variance, right? And also the third one is standard deviation. So mean representing what? Measure of central tendency. Standard deviations represent what? And variance presenting a measure of dispersion, deviation. Standard deviation. So those are the parameters that we may use. We may use the formulas, we may use estimations to estimate by using the sample that has been drawn from either finite or infinite population. And we simplify life as engineers. We design systems to solve real life problems which are not too much complicated, because that's the task of an engineer or a scientist to simplify life by designing different systems. So that's the definitions of 40 of estimation, right? So then I would like to ask you that to allow me to touch, just to introduce to you something important that we say. I would like just to introduce to you a good estimator. So we say that to estimate the population sorting parameters. Okay. So we say that in order to estimate a particular statistical, or we call it population parameter. For example, mean population, particular population parameter, such as mean or variance or standard deviation, which is SD Then we have to choose or to select it. Yes, to choose a good estimator. A good estimator. Say estimator. So in other modules that being taught on base of knowledge of computers based, we define what the means of estimator. But for these modules, it's not a requirement. But they're not limited to know what the means of estimator. So a good estimator. So you say that again, statisticking, we say that a good estimator, now in engineering mathematics or in statistical mathematics must have the following properties. So must have the following properties. Okay, what are the properties? The first property, a good estimator should be unbiased. Biasness. Secondly, the good estimator should be efficient. So this is the efficiency. And thirdly, we say the good estimator should be consistent. So a good estimator should be unbiasedness, and then a good estimator should be efficient, and a good estimator should be consistent. So those are the three properties for a good estimator. Three properties for a good estimator. Okay. So because these are the three properties for good estimator, let me teach you and explain to you what the means of each property. Let us start with the word unbiased, unbiasedness. Say unbiasedness. Okay. So we'll be speaking too mathematically in this case. We say that an estimator for population parameter is said to be unbiased if. So unbiasedness of estimator, we say that simply we say that the value of, we say that the estimator is saying unbiasedness if, say that the estimator is said unbiasedness if its value is equal to the actual or true value, of population parameter that, or 40 of population parameter that has been estimated. So you say that say to be unbiased if, so it is, so let's say for example we have a parameter, so let's say an estimator, mathematics now, an estimator that we call it theta, right? For a population, let's say we have kept there for an angle for representing a certain population parameter, such as mean, right? For a population parameter. So this is unbiased estimator at the meaning population parameter theta. So the population parameter is theta, and this is sample parameter, right? So theta is said to be unbiased, because you are biased and unbiased if and only if the estimation of this sample estimator is equal to the actual value of population parameter. So this matter. So E stands for estimation. This is the there's the sample parameter, and this is the population parameter. So if the estimations of this sample parameter is equal to the population parameter, then we say that that estimator is what? Unbiased. So the quantity that runs is called the bias of theta. So for this case, we say that means that the estimator of the populations is equal to the actual parameter of the populations. So say that if they are equal, it's called the bias of theta. So it means that now the parameter, the sample parameter is the bias of population parameter theta. Right? So this is the bias of population parameter theta. So that is the first property. The second property is efficient. Say efficiency. You have efficiency and also you have consistency. So let me teach you efficiency. Okay, so I think that I will teach you in the next lecture the second property, which is efficiency and consistency. I would like just to say that this is the end of lecture 1 or sessions 1 of the modules called the statistics for non-measures for universities and the knowledge-based knowledge. I'm Sir Olenjolai TAYAI. I thank God who have prepared me to teach this module, and I thank God who have helped me to teach these modules, and I thank God who have helped you to understand and join me in these channels, and I'm praying that you have to understand more than I do. And also, I thank you for taking your time. Subscribe, remember to share this material, and join me in the next lecture. May God bless you. I'm praying for you, and then pray for me. See you in the next lecture. May God bless you.